In this video, we will solve PIEAS past paper. Question 1 says that the magnitudes of dot and cross products of two vectors are 6 under root 3 and 6 respectively. The angle between the vectors is, from the question, we know that the dot product, which is A dot B, is equal to A B cos theta, which is equal to 6 under root 3. While the cross product, which is A cross B, is equal to A into B sine theta, which is equal to 6. Now to solve for the angle, we will find the ratio between them. So we can write it as the dot product over the cross product is equal to AB cos theta over AB sine theta. Now this B cancels this B, this A cancels this A. Now we have cos theta divided by sine theta, and it is equal to 6 under root 3 divided by 6. So here this 6 cancels out this 6. So we have tan theta under root 3. By solving it, we will get theta is equal to 30 degrees, which is option A. Therefore, option A is the correct answer. Question 2 says that a ball is thrown from the ground to clear a wall of 3 meter high at a distance of 6 meter and falls 18 meter away from the wall. The angle of projection will be, according to the question, a ball was thrown which cleared a wall of 3 meters which was 6 meters away, and the ball lands further 18 meters away from the wall. So the total range will be 6 meters plus 18 meters, which is 24 meters. From the equation of trajectory, we know that y is equal to x tan theta 1 minus x over r. In this equation, y is 3, x is 6 and range is 24 meters. By putting values and solving it, we will get tan inverse 2 over 3. Question 3 says that a body of mass m is allowed to fall freely through height h under gravity. The ratio of its kinetic energy gained to linear momentum gained is, we know that the kinetic energy is given by this formula, which is 1 over 2 mv square, while the linear momentum is given by this formula. According to the question, the velocity square is equal to 2gh. So we will have velocity as under root 2gh. If we substitute this value of v in equation number 1 and equation number 2, we will have kinetic energy as 1 over 2 m under root 2gh whole square. This square cancels the under root and this 2 cancels this 2. So the kinetic energy will be mgh. While talking about the linear momentum will be p is equals to m under root 2gh. If we talk about the ratio will be kinetic energy over linear momentum. So we will have mgh divided by m under root 2gh. This m cancels this m. We will have gh divided by under root 2 under root gh. By simplifying it, we will get under root gh divided by 2, which is option C. Therefore, option C is the correct answer. Question 4 says that a motorcyclist is moving inside a spherical of radius 5 meters. The minimum speed with which he must pass the highest point without losing contact is, here gravity is 10 meters per second square. The radius of the spherical is 5 meters and the gravity is 10 meters. So we have the centripetal force, which is Fc is equal to mv square over r. At the highest point, the force is equal to the weight. So we can say that mg is equal to mv square over r. Now this m cancels out this m, and if we solve for v square, we will have gr By simplifying it, we will have V is equals to under root GR. By putting values, we will get 10 into 5, which is equal to under root 50, which is then equal to 5 under root 2, which is option number B. Therefore, B is the correct answer. Question number 5 says that three charges, each of 4 microcoulomb, are placed at the three corners B, C, D of a square ABCD of side 1 meter. The electric field intensity at center point O, as shown in the figure, is. Now, in this question, we have to find the electric field intensity and its direction as well. So, talking about the direction, if this is the center, this D charge puts its electric field towards this direction and B puts to this direction, then these both charges cancel out their forces. Then we have the C charge, and the C charge applies force towards this side, and this is the direction of A. Therefore, we can say that the electric field applied is towards A. Now, to calculate the electric field, we know that the electric field is given by 1q divided by 4 pi epsilon naught r square. If each side is 1 meter long, then the radius will be 1 over under root 2. By putting the values, we will have 9 into 10 raised to the power of 9 into 4 into 10 raised to the power of minus 6 divided by 1 over under root 2 whole square. By solving it, we will get 7.2 into 10 raised to the power of 4 Newton per coulomb towards A, which is option number A. Therefore, option A is the correct answer. Question 6 is that the temperature coefficient of resistance of wire is 0.00125 coulomb inverse at 300 Kelvin. Its resistance is 104 ohm. The resistance of wire will be 2 ohm at. Now we know that the initial resistance at 300 Kelvin is 1 ohm. Let T be the temperature when final resistance is 2 ohm. So you can find out the temperature at final resistance by this formula, which is, so we have 1 over 2 is equal to 1 plus 0.00125 into 27 divided by 1 plus 0.00125 into T. By solving it, we will get our temperature as 854 degrees Celsius, which is, if converted into Kelvin, will be 1127 Kelvin, which is option D. Therefore, option D is the correct answer. Question 7 says that an electron is moving with velocity of 6.6 into 10 raised to the power of 5 meter per second. Its de Broglie wavelength is, we know that de Broglie's wavelength can be measured by this formula, which is lambda is equal to h over mv. Here v is the velocity, h is the Planck's constant, and m is the mass of electron. We know that h is equal to 6.626 into 10 raised to the power of minus 24 joule second, and the mass of an electron is equal to 9.109 into 10 raised to the power of minus 31 kilograms, and the velocity is given in the question. By putting these values in this formula and solving it, we will get option A, which is 1.1 into 10 raised to the power of minus 9 meters. Question 8 says that a spring constant 5 into 10 raised to the power of 3 Newton per meter is stretched initially by 5 centimeters from the unstretched position. Then the work required to stretch it further by another 5 centimeter is. Now, according to the question, we have the spring constant, which is K, and the initially stretched position, which is 5 centimeter. And if we convert it into meters, we will have 5 into 10 raised to the power of minus 2 meters. Now first, we will calculate the work done to stretch the string initially. So we can write it as W1 is equal to 1 over 2 kx1 whole square. By putting values and solving it, we will get 6.25 joule. Now we will calculate the total work done after switching the string. So we can write it as W2 is equal to 1 over 2 kx2 whole square is equal to, now here x2 will be x1 plus 5 centimeters. As we have to stretch it for another 5 centimeters, so it will be 10 into 10 raised to the power of minus 2 meters. By putting these values in this formula, we will get 25 joule. Now to calculate the work done in stretching the string, we will just subtract W1 from W2 and our answer will be 25 minus 6.25, which is equal to 18.75 Newton meters, which is option B. Therefore, option B is the correct answer. Question 9 says that a cylinder of height 20 meters is completely filled with water. The velocity of the efflux of water in meter per second through a small hole on the side of the wall of the cylinder near its bottom is. In the question, we have the height. And to calculate the velocity, we have a formula which is V is equal to under root 2gh. Here height is 20 meters and gravity is 10. So we will just put in the values which are 2 into 10 into 20, which is equal to 20 meters per second, which is option B. Question number 10 says that a lift is moving with acceleration A. A man in the lift drops a ball inside the lift. The acceleration of the ball as dropped by the man in the lift and a man standing stationary on the ground are respectively. Now here I have a lift. If a person is standing here and he throws the ball here. Now we know that the acceleration of lift with respect to gravity is A. So the acceleration of ball with respect to the ground will be the gravity, which is G. And then the acceleration of the ball with respect to the person who is standing in the lift will be acceleration of ball with respect to lift as acceleration of ball with respect to gravity minus acceleration of lift with respect to gravity, which will be G minus A. Therefore, we can say that it is G minus A and G, which is option C. Question 11 says that two spheres of the same material have radii 1 meter and 4 meter and temperature 4000 Kelvin and 2000 Kelvin respectively. The ratio of energy radiated per second by first sphere to that by the second is. According to the Stefan's law, we know that the power is equal to sigma A E T raised to power of 4. Here, sigma is Stefan's constant, A is surface area, E is emissivity of material, and T is temperature. Now we have R1, R2, and T1, T2. So we will have P1 as sigma A1 E T1 4 and P2 as sigma A2 E T2 4. By calculating the ratio, we can write it as this. Here, this sigma cancels this sigma and this E cancels this E as they both are made up of the same material. Now we will have A1 T1 raised to power of 4 and A2 T2 raised to power of 4, and by putting values in it and solving it, we will get 1 over 1, which is option A. Therefore, you can say that the energy radiated per second by the first sphere to that by second sphere is 1:1. Question 12 says that the bending of a bimetallic strip when heated is primarily due to. Now we know that in a bimetallic strip we have two metals, and when this metal is heated, these two metals expand at different rate because of the difference of the coefficient of thermal expansion. This difference in expansion causes the strip to bend. The metal that expands more is on the outside. If this part is being heated, this metal will expand like this, and this metal will expand like this. So we can say that the metal that expands more is on the outside of the curve. Therefore, we can say that the unequal expansion of two metals, which is option C, is the correct answer. Question 13 says that an automobile traveling with a speed of 60 km per hour can brake to stop within a distance of 20 meters. If the car is going twice as fast, that is 120 km per hour, the stopping distance will be. Now here we have the initial speed of the automobile, which is u1, which is equal to 60. And then we have the final speed of the automobile, which is v1, which is equal to 0. And then we have the initial speed of the car, which is u2, which is equal to 120, and the final speed is v2, which is equal to 0. Now we have the stopping distance, which is 20 meters. We know that the third equation of motion is equal to v square is equal to u square plus 2as. Now we can write it as u square is equal to v square minus 2as. Now we will write this equation for the car and the automobile. Here, in both of these vehicles, the v will be 0 as v1 is 0 and v2 is 0. So in case of automobile, we can write it as u1 square is equal to minus 2as. And for car, we can write it as u2 square is equal to minus 2as2. Now, if we divide this equation by this, we will get u2 divided by u1 whole square, which is equal to s2 over s1. By putting values, we will get 120 divided by 60 whole square, which is equal to s2 divided by 20. By solving it, we will get s2 as 80 meters. Therefore, option D is the correct answer. Question 14 says that a particle is acted upon by the force of constant magnitude, which is always perpendicular to the velocity of the particle. The motion of the particle takes place in a plane. It follows that since the particle is acted upon by a force of constant magnitude, which is always perpendicular to the velocity of the particle, so the work done by the force will be 0. So the magnitude of the velocity will not change. We know that the kinetic energy is equal to 1 over 2 mv square. So mass and velocity will also be constant. Therefore, the kinetic energy remains constant. So we can say that option C is the correct answer. Question 15 says that in an LCR series AC circuit, the voltage across each of the component L, C and R is 50 volts. The voltage across the LC combination will be, according to the question, we know that VL is equal to VC, which is equal to VR, and all of these are equal to 50 volts. As VL and VC are equal in magnitude and opposite in phase, we can calculate their phasor sum by the formula, which is VLC is equal to VL plus negative VC. This negative sign here represents that VL and VC are equal in magnitude but opposite in phase. By putting values, which is 50 plus minus 50, we will get 50 minus 50 as 0. Therefore, option D is the correct answer. Question 15 says that when NPN transistor is used as amplifier. So the options are electrons move from base to collector, holes move from emitter to base, electrons move from collector to base, and holes move from base to emitter. Now we know that NPN transistor consists of an emitter, base and collector. When we apply small current to the emitter, it allows electron to flow from emitter to base and then base to collector. The output is amplified. Therefore, we can say that option A is the correct answer, which is when electrons move from the base to the collector, the signal is amplified and the transistor works as an amplifier. Question 17 says that a charged oil drop is suspended in uniform field of 3 into 10 raised to the power of 4 volts per meter so that it neither falls or rises. The charge on the drop will be, take the mass of the charge as 9.9 into 10 raised to the power of minus 15 kilogram and gravity as 10 meters per second square. So in this question we have the electric field, which is this. And then we have the mass of the charge and the gravity. At equilibrium, the electric field of drop balances the weight of the drop. Therefore, we can write it as QE is equal to mg. As we have to calculate the charge, we will simply solve it for Q, which will be mg divided by E. Now here we have the electric field, the mass of the charge and the gravity. By simply putting values and solving it, we will get 3.3 into 10 raised to the power of minus 18 coulomb, which is option A. Question 18 says that a piece of copper and another germanium are cooled from room temperature to 77 Kelvin. The resistance of, we know that the resistance of a conductor is directly proportional to the temperature. So we can write it as RC is directly proportional to the temperature. And that of a semiconductor is inversely proportional to the temperature. So we can write it as RSC is inversely proportional to the temperature. Here, copper is a conductor while germanium is a semiconductor. When the temperature is decreased, the resistance of the copper decreases and the resistance of the germanium increases, which is our option C. Question 19 says that when uranium-235 decays by alpha particle emission, the daughter nuclei formed is. Now we know that when a uranium-235 emits an alpha particle, which is an helium particle. So the new particle which will be produced will have atomic number 92 minus 2, which will be 90. And its mass number will be 235 minus 4, which is 231. So according to the options, we have thorium. Therefore, A is the correct answer. Question 20 says that two charged spheres are separated by 2 millimeters. Which of the following would produce the greatest attractive force? Now, if we have two charged particles with a distance of 2 millimeters, so to have the attractive force, we must have opposite charges, which is plus and minus. This attractive force will be maximum when both charges are same. Therefore, according to our option, we have positive 2q and negative 2q, which is option D. Therefore, D is the correct answer. Question 21 says that when X-rays are scattered by electron, their wavelength. We know that when X-rays are scattered by electrons, this phenomena is known as Compton scattering. So when the X-ray photon transfers some energy to the electron, it causes the wavelength to increase due to the conservation of momentum and energy principle. Now here I have an electron. If an X-ray hits it, then its wavelength will increase. Therefore, we can say that A is the correct answer. Question 22 says that a point charge at a distance x from another point charge experiences a force of repulsion. Which of the following graph shows how the force is related to x? According to Coulomb's law, the force between 2 point charges is inversely proportional to the square of the distance between them. So mathematically, we can write it as F is inversely proportional to the square of their distances, which is this. Now, according to our graphs, we have option B as our correct answer. Question 23 says that the moon rotates about its axis. In future, scientists may wish to put a satellite into an orbit around the moon such that the satellite remains stationary above one point on the moon's surface. The period of rotation of the moon about its axis is 24.7 days. Calculate the radius of required orbit. So mass of the moon is 7.35 into 10 raised to power of 22 kilograms. According to the question, we have the period of rotation which is 27.4 days. If converted in seconds, we will have t is equal to 2367,360 seconds. Now we have the mass of moon and we know that the gravitational constant of the moon is 6.674 into 10 raised to the power of minus 11. So according to the Kepler's third law, we have t square is equal to 4 pi square r cube over g mm. When we will solve it for r cube, we will have g mm t square over 4 pi. After putting values and solving it, we will get r cube is equal to 6.9 into 10 raised to the power of 23. When we will take the cube root, we will get 4.23 into 10 raised to the power of 7 meters, which is option C. Question 8 says that two sinusoidal voltages of same frequency are shown in the figure. What is the phase relationship between the voltages? From the graph, you can see that the M reaches its maximum value at 0.1, while N reaches its maximum value at 0.2. And according to the graph, we can see that the waves complete their cycle in 0.4, which is the period. Therefore, we can say that it is the period. If we calculate the change, which will be del V, which is equal to 0.2 minus 0.1, which is equal to 0.1. So the phase angle will be del phi is equal to del V divided by the period into 2 pi. By putting values, we will get pi over 2. Now here we can see that n lags m, so we will add a minus to it. Therefore, we can say that B is the correct answer. Question 25 says that a photocell is illuminated by a small bright source placed 1 meter away. When the same source of light is placed 0.5 meters away, the number of electrons emitted by photocathode would. We studied that the number of photoelectrons are inversely proportional to the distance squared. Now, according to the question, the distance is halved. Therefore, we can say that 2 square is equal to 4. So we can say that this distance is decreased by 4. So the photoelectrons will increase by a factor of 4, which is option B. That's all for this video.